All right, so this is, I guess, the first one of these I've done for this particular group. Chapter 37, the interference, diffraction, and polarization. All right, so chapter 37, I'm hoping that you can see that on the video. All right, so one of the issues when dealing with light was the wave versus particle debate. Newton was a particleist, and Huygens was a wavist. And this set up a bitter dispute between the two. And basically, at the time, history decided that the wave property seemed to work the best. And one of the big pieces of evidence for the wave was this idea of interference. We've talked about constructive and destructive interference, and the same holds true for electromagnetic waves just as much as it does for mechanical waves. So there's a very simple experiment. If you imagine that I have a wall right here and I have a set of waves coming in. So that's my wall. I have a set of waves coming in. When the waves hit the opening right here, they're going to part of it's going to go through. Some of the wave is going to hit the wall and bounce back. Part of the wave is going to go through. And you should be getting these wave patterns like that, where they sort of go out in a circular fashion. Now, in and of itself, if I shine a light at a hole like that, I'm not necessarily going to see anything. I actually will, but they were not initially thinking of that. But they did set up what's known as the double slit experiment. So the wave comes in, and it hits this, and suddenly you get these waves coming through both of them. And now you have these overlapping waves. Now, if you recall back to when we were dealing with mechanical waves, these lines right here represent the peaks. So if I had a mechanical wave looking like this, I can express this in sort of an overhead point of view as a series of lines at the peaks. So the points where I have these two waves meeting, I should be able to get, it's constructive interference, and so I should be able to get brighter light than, so let's say, the point right here. So this is constructive interference. Interference. And this point right here, in between the two waves of the waves coming out of the top slot right here, this is halfway in between, and so this is when this wave is bottoming out, and the line right here coming from this slot right here is when it is peaking. So we basically have a wave that is peaking when the other one is bottoming out, and that is destructive interference. And destructive interference in terms of light would be a dark spot. So we'd have a bright spot and a dark spot right there. So if I took a screen, so if I took my double slits there, and then I took a screen, as light comes through it, what I would expect is smack dab in the middle, I should have the brightest spot, and then there should be a dark spot, and then another spot that's not quite as bright, but still noticeable, and then a dark spot, and then not quite as bright, then a dark spot, and so on. And we should see this pattern like this if the light is indeed a wave. And in fact, we do see this. And that'll be a video later on where I try to do it. It needs to be dark in order to really show it properly. So not 100% sure what's going to happen there, but this is known as the double slit experiment. And this was the huge evidence for the light being a wave. Now, once you get into the 20th century, they suddenly realized, wait a second, there's some particle aspects also, and we'll talk about that after chapter 37. So that is the double slit experiment, and I'm going to leave that as an introduction. The next video, just as a teaser, the next introduction, we're going to actually go through and derive some equations, and just to see how well that works. So this is the introduction to interference.